Welcome to the deep dive. Today we're getting into something really core for anyone aiming for those senior software engineering roles, especially, when distributed systems pop up.
Absolutely.
Think about it. Multiple databases, all working together. What happens when they kind of disagree on a change? We're going deep on write conflicts and multi-leader replication. Seriously, essential stuff if you want to show you really get system architecture, not just coding basics.
Exactly. It's like imagine you've got your data spread out, maybe for speed or resilience, right? Multi-leader replication lets multiple places accept writes, but what if two people change the exact same thing at basically the same time, but hit different leaders? That's the crux of it.
Okay, yeah, let's make it concrete, like a Wiki page.
Yep.
Starts with title A. User 1, maybe in Europe, changes it to B on their local leader. Almost instantly, user 2, say over on the U.S. West Coast, changes that same original A to C on their leader. And locally, both changes are fine. Each leader says, yep, got it.
And that initial success, that's a big plus for multi-leader setups, right?
Yeah.
You get better availability, maybe lower latency for users close by. But the trouble starts when those leaders try to chat and share their updates.
Right. So leader 1 tells leader 2, hey, record 123 is now B, used to be A. But leader 2 is like, hold on, I have C here. It can't just overwrite it.
Yeah, and vice versa. Leader 2 tells leader 1 its C was A, and leader 1 is sitting there with B. They both thought they were making a valid change based on A, but now conflict. This just doesn't happen in a single leader world where writes line up nicely.
So this raises a big question then. When do we even realize this mess happened? Could you, detect it instantly?
Well, you could try synchronous detection, meaning a write isn't done until all leaders agree and any conflicts are flagged right away.
Okay, but wait. Doesn't that kind of kill the whole point?
Yeah.
If you have to wait for everyone to sign off, you lose that speed and independence that multi-leader is supposed to give you.
Precisely. You nailed it. That's why asynchronous detection is way more common. The conflict pops up later during the normal replication chatter. It keeps writes feeling fast, but yeah, you've got this delayed problem to solve. And like we said, by then, asking the user which title they wanted, probably too late. It's that classic trade-off, immediate consistency versus availability and write speed.
So if detecting them immediately is kind of counterproductive, can we just stop them from happening? Avoid the whole conflict thing. That sounds ideal.
Absolutely, and conflict avoidance is definitely a strategy people try. The basic idea is make sure all writes for one specific record always go to the same leader.
How would that work?
Well, imagine users editing their own profiles. You could just route all of my edits to the leader in, say, the East US data center. All of your edits go to the West EU leader. For that specific user's data, it feels like a single leader system.
Okay, that makes sense for user-specific data. But what if, the East US data center goes down? Or I move to Europe and now the West EU leader makes more sense for me.
Exactly. Those are the cracks in the avoidance strategy. If the designated leader has to change, maybe because of an outage or a user moving, there's this window where writes might hit both the old and the new leader before everything settles, and boom, you're potentially back in conflict territory.
Okay, right. So avoidance helps, but it's not a silver bullet. Conflicts can still sneak in. So we need a plan B. We hear this term convergence. What's that actually mean for our wiki titles B and C? What's the end goal?
Convergence just means that eventually all the replicas, all the leaders have to agree on the same final answer. Can't stay B over here and C over there forever. The system has to settle on one value. If every leader just applied updates whenever they arrived, you'd get that permanent split brain state, totally unacceptable. So convergence is non-negotiable for any multi-leader system.
Makes sense. So how do we actually get to that single agreed upon title? What are the common ways systems resolve these fights? This sounds like prime interview material.
Yeah, definitely. There are a few main approaches, each with pros and cons. A really common one is last write wins, or LWW.
Last write wins. Okay.
The idea is simple. Every write gets a unique ID, usually just a timestamp. When there's a conflict, the write with the highest timestamp, the last one wins. All others get tossed out. It basically prioritizes recency, assuming the latest change is the right one.
Simple, yeah, but feels risky. What if the last write, timestamp-wise, isn't actually the one the user meant to be final? Couldn't we lose data that way?
Big time. That's the major downside of LWW. If your server clocks aren't perfectly synced, and they never are, really, or if there's just a bit of network lag,
Right.
an older write could arrive after a newer one and overwrite it. So yeah, LWW is popular because it's easy and guarantees convergence, but data loss is a real possibility.
Okay, so if timestamps are messy, what else? Any other automatic ways to pick a winner?
Yep. Another tactic is giving each replica, each leader, its own unique ID number. When a conflict happens, the write from the replica with the higher ID, or lower, depends how you set it up, wins.
So like leader #5 always beats leader #2.
Basically, yeah. Again, it's deterministic, it guarantees convergence, but just like LWW, it's arbitrary. The winning write might not be the correct one from a user's perspective. Still potential data loss.
So both automatic options risk throwing away potentially good data. What about trying to merge the conflicting values, combine B and C?
That's another approach, value merging. In the Wiki example, instead of picking B or C, maybe the system combines them, like concatenates them alphabetically, BC.
Huh. Okay, so you don't lose either B or C.
Oh.
But now the title is BC, which is probably not right either. Seems like you're just kicking the can down the road.
Pretty much. You avoid outright loss, but you often end up with a weird, possibly nonsensical value. It means something or someone, application code, maybe even a human, still has to step in later and clean it up to get the real intended value.
Okay, so if losing data is bad and merging can be messy, are there other ways? Ways that maybe keep all the info?
There is. You can explicitly record the conflict. Instead of the system trying to be clever and pick a winner or merge, it just stores all the conflicting versions, B and C.
Ah, I see.
Then the job of sorting it out falls to the application logic when it reads the data, or maybe even presents the options to the user. No data loss, but definitely more complex code needed to handle reading and resolving those multiple versions.
That makes a lot of sense. Put the decision where there's more context.
Mm.
You also mentioned custom conflict resolution logic earlier. How's that fit in?
Right, because often the best way to resolve a conflict depends entirely on what the data means in your application. So many systems let you write your own code to handle conflicts.
Well, your own logic, okay.
Yeah, this custom code can run either when the conflict is first detected during replication, we call that on-write resolution, or later when someone tries to read the data that has conflicting versions on read resolution. It gives you ultimate flexibility.
Wow.
But adds complexity. And, you could write buggy resolution logic yourself.
Can you give an example? Like, where would custom logic be really useful?
Sure. Think about something simple like a likes counter on a social media post. If two leaders both increment the counter at the same time, LWW might just lose one of the likes.
Right, because one write overwrites the other.
Exactly. But with custom logic, you could say, if there's a conflict on a counter, don't just pick one value, add them together. Or maybe always take the highest value. Some databases let you plug in little code snippets for this on-write stuff. Others, like CouchDB, for example, might just give you back both conflicting versions when you read, and your application code then figures out what to do. Maybe show the user both versions and ask.
Okay, so lots of power there, but also responsibility. You have to really understand your data and what a correct resolution means.
Absolutely. And it's easy to get wrong. There's that classic story about the Amazon shopping cart where, because of how they handled conflicts to make sure nothing added got lost, sometimes items people had removed would mysteriously reappear later. It just shows how tricky automatic resolution can be, even for smart engineers. Those unintended consequences can be really surprising, sometimes funny, sometimes just frustrating for users.
Wow. Yeah, highlights the challenge. So it sounds like automatically getting this right is still tough. Is there newer research, maybe better ways coming down the pike?
Oh, definitely. There's some cool stuff happening. One big area is conflict-free replicated data types, or CRDTs.
CRDTs?
Yeah, think of them as special data structures, like sets or counters designed from the ground up to handle concurrent edits automatically and correctly. So that likes counter example. A CRDT counter would just naturally end up with the right total, even with concurrent increments without needing special conflict code.
Okay, that sounds promising. Anything else?
Well, there's also work on mergeable persistent data structures, kind of inspired by how Git merges code branches. They track history and try to merge changes intelligently. And then there's operational transformation, or OT. That's the magic behind things like Google Docs, where multiple people edit live.
Oh, okay.
OT focuses on transforming the edit operations themselves based on what others are doing, so everyone ends up seeing the same thing. Getting these ideas into general databases is still ongoing work, but they could really simplify multi-leader setups in the future.
Interesting. So we've mostly talked about conflicts like changing the same title field, but you mentioned conflicts can be more subtle. What did you mean by that?
Yeah, it's not always just two people editing the exact same bit of text. Imagine a meeting room booking system using multi-leader replication.
Okay.
Leader A checks room 101, sees it's free from 2, 3 p.m., and books it for Team Alpha. Almost simultaneously, Leader B also checks room 101, sees it's free from 2, 3 p.m. because Leader A's booking hasn't replicated yet, and books it for Team Bravo.
Uh-oh. Double booked.
Exactly. Each leader thought the booking was valid based on the info it had at that moment. But looking at the whole system, you violated a core business rule. The room can only have one meeting. This isn't a direct data collision on one field. It's an application-level conflict caused by concurrency in the multi-leader setup. Even if you have checks, timing can still bite you. So what counts as a conflict really depends on your application's rules.
Gotcha. It's broader than just two writes hitting the same data point. It's about maintaining overall system consistency according to business logic.
Precisely.
Wow, okay.
Okay.
This has been really clarifying, a proper deep dive into right conflicts and why they matter so much, especially for senior roles. So I guess the big takeaway is multi-leader replication. Great for availability, great for speed sometimes, but you absolutely have to grapple with right conflict.
I was taping it.
And there's no magic answer, right? It's all trade-offs. Last right wins, merging, custom logic. They all have implications for data integrity, how complex your system gets, and what the user actually experiences.
Absolutely. And for anyone prepping for those interviews, being able to talk through these different strategies, LWOW, replica IDs, merging, recording conflicts, custom logic, CRDTs even, and discussing the pros and cons, that shows you're thinking about distributed systems at the right level. It's not just about knowing the terms, but understanding the consequences of these design choices.
Definitely. So maybe a final thought for everyone listening. Think about how the application itself changes things. How would you approach conflict resolution differently for, say, bank transfers versus maybe editing a shared document? What level of consistency is critical and what can you maybe live with? How does that choice impact the user? That's where the really interesting design decisions lie. Thanks for joining us for this deep dive.